seen linear inequalities before, but now we are going to create a system just like we did our linear equations. So we know step number 1 is that we need to solve for y in both inequalities. And just to remind ourselves that we would flip the direction of the inequality symbol if we had to multiply or divide by a negative number. So just to kind of reiterate that, if we divided by a negative number or if we multiplied by a negative number, we would have to flip the inequality symbol. We're going to graph just like we always do, plot out the y-intercept, count out the slope. Solid line, you would use a solid line if it's less than or equal to, greater than or equal to, or just straight up equal to, which wouldn't be an inequality, but just FYI. Dash line, greater than, less than. We would shade above if we have y is greater than or y is greater than or equal to. We would shade below if we have y is less than or y is less than or equal to. The solution set is going to be in the double shaded region. So we have to make sure that it's where the shading overlaps. That is the solution for the system of linear inequalities. On our first one, the first inequality is solved for y, so that's great. But what we need to do is on the second one, we need to go ahead and isolate the y so that when we graph it out, we'll be ready to go. What I would do when I'm working on finding the solution for this set, go ahead, add 3x to both sides. That's going to give me negative 4y is greater than or equal to 3x minus 12. Next up, I would divide by the negative 4. And I do that to every single thing I see. That it will flip the sign and give us a slope of negative 3/4 x, and then negative 12 divided by negative 4 is positive 3. So now I can go ahead. Here's my first inequality to graph. There's my second. Let's go ahead and go with the first one first. So my y-intercept is negative 5. So I will go down to negative 5 and I'll put a point and then count out my slope. Up 2 over 1, up 2 over 1, up 2 over 1. As you can see, I'm just continuing it out because it would be a dashed line anyway. So I'm just going to get that out there. You can also go the other direction if you would like. That's my first one. It is y is greater than. So would you shade above or would you shade below? Well, if it's greater than, we're going to shade above. And I'm going to try to keep it simple so that we can see where they overlap. Let's see if we can see it easily. So there's for my first inequality. Now my second inequality, y is less than or equal to negative 3/4 x plus 3. My y-intercept is 3. My slope is negative 3/4. That means we're going to have to go one direction and then the other. Meaning, if I go down 3, I'd have to go to the right 4. Or if I went up 3, I'd have to go to the left 4. So that my line is decreasing. This one will be a solid line, so go ahead and connect those points together. And then it's less than or equal to, so that's going to be shaded below. So here's where we can kind of see the overlapping. Oops, I didn't put arrows on my other one, so I'm going to do that real quick. Here's where we can see the overlapping. And that's kind of when I wanted to do it pretty simple. Is in this area right here, you should see those two different directions of the lines overlap. And if I follow it up with a highlighter, it's going to be this like little slice right here, anything in this area would be the solution. This is the solution set. So again, we have to remember that it does have to be shaded for both of the lines or double shaded region, so that you know that if you pick a point here, it's going to make it truthful for this positive slope inequality. It's also going to be truthful for the negative slope. So any point in this shaded area, forever and ever that way, that would be part of your solution set. Flipping it on over to the back. This first one is kind of nice because it's already solved for us, so we don't have to do too much on it. But we do have to graph it out. So let's go ahead and do that. Looking at the first one, our y-intercept is 3. And our slope is -4/3. Okay. Solid or dotted? It's going to be a solid line, because when you look at the less than or equal to, that's telling you that everything is included. Less than, shade below. Real simple. And then move on to the next one. X is greater than 2. Don't let this trick you. That is a vertical line, just like it always is. Greater than, that's going to be a dashed or dotted, whichever one you want to think of. Vertical line going through 2. And then it is greater than, so that's going to be shaded on the numbers side. That's going to be more than the 2, which would be over here to the right. It's a little bit different when it's a vertical line, but I know we can handle it. And then what we would see is that in this area here, it is shaded for both of them. So that area would be our solution set. So kind of the big idea is whenever you shade them, just think about where do they overlap, and that's going to be your solution set, because anywhere in this area, like I said before, when you pick a point, it's going to make the inequality for the -4/3 x plus 3 true, and it will make the inequality x is greater than 2 true. Okay, when we are writing or formulating systems of inequalities, some key phrases that we see. This is a less than sign, so we might see that phrase is less than. We might see fewer, fewer than, or we might see below. Those are some kind of key phrases when we're talking about the less than sign. Less than or equal to, maybe we see at most. Maybe we see maximum. I'll put max for short. You might see no more than. Another key phrase is at or below. For the greater than sign, you might see exactly that. Greater than. Maybe you see more than. Maybe you see just above, keeping it simple. Greater than or equal to, at least or minimum, no less than, at or above. Kind of phrases you're going to look out for whenever you are writing those inequalities. Last but not least, word problem, dealing with inequalities. And on this one, we are just going to write the system. We are not going to solve it. So let's go ahead and read it. Mary babysits for $4 per hour. She also works as a tutor for $7 per hour. She is only allowed to work for at most 13 hours per week because she needs to focus on her schoolwork. She wants to make at least $65 a week. Write a system of inequalities to represent this situation. So the first thing we always like to do is we go ahead and define our variables. So let's label babysitting as our X variable, and let's label tutoring as our Y variable. And I'm just going to run back through there. So babysits for $4 per hour. So if X is babysitting, I know that you're making $4 per hour babysitting. That's what that means right there. She also works as a tutor for $7 per hour. Well, we define tutoring as Y, so that would be 7Y. And then it goes on to say she is only allowed to work at most. That's going to give you your inequality to use, 13 per week, because she needs to focus on her schoolwork. She wants to make at least 65 per week. And we're writing the system. So let's start with inequality 1. Let's go ahead, let's do the 4x and the 7y. So that's going to be our money. Money sign, money sign, money sign. 4x plus 7y. And $65 is what she wants to make at least. So she wants to make 65 or more. So greater than or equal to 65. She's only allowed to work at most 13 hours per week. So she can work 13, but she can't work anything else above that. So you would say that 13 is going to be that maximum. So she could either babysit or tutor for the 13 hours. But whatever she's doing here has to be less than or equal to 13. She cannot go over that 13 hours. So this system would be 4x plus 7y is greater than or equal to 65. X plus y is less than or equal to 13.